Hi, my name is Aneta and this is Chemistry at Glance. In today's video, we are going to practice some past paper questions on calculating reactant masses and the empirical and molecular formula. If you're not familiar with the topic, I leave the links in the description box below with the links to my blog where I post all the tutoring video post. So if you're still here, I believe you want to carry on with these questions. So this is the first one. Find the empirical formula of the compound formed when 1.172 grams of iron forms 3.409 of a chloride. What this means is that iron, when combined with chlorine, will give you chloride, so an iron chloride. And you gotta find the MR of this iron chloride. So we know the amount of iron that was used, which is 1.172, and the amount of chlorine that was used we also know because we can do 3.409, which is the mass of the finishing product, minus the mass of iron, and this gives you 2.237 grams of chlorine that had to be used, because the mass of the reactants will give you the mass of the product. So what you're going to do now is start with the steps. I explain all the steps in my blog. So first thing we want to do when you're trying to find an empirical formula is to find the MR of both substances taking place. So all the elements that are present in the compound for which you're trying to find the empirical formula. So the first step is to find the relative atomic mass. And this is the top number of the elements. So for iron, it's going to be 55.8. And for chlorine, it's going to be 35.5. This is our first step. So the next step is to find the mass of these. And these were given to us in a question. This is sometimes given as a percentage as well, but it doesn't matter, it can be a percentage. And our last thing, the very big step, step number 3, is to find the N, so the number of moles of both of them, in order to find the molar ratio between them. So in order to find N is mass over MR. For iron, it's going to be 1.172 over the MR, which is 55.8, and this gives us 0.021. For chlorine, it's going to be 3.409 divided by 35.5, which is our MR, and this gives you 0.063. What we do next is divide by the smallest. So the smallest of these two is 0.021, so you divide by 0.021. This gives you 1. Divide this one by 0.021 as well, and it gives you 3. So this is our ratio, 1 to 3, Fe1, Cl3. So this is our ratio, and this is our formula. And the next question. A chloride of sodium, which is used to bleach pulp, has a percentage composition by mass of Na 21.6%, Cl 33.3%, and oxygen 45.1%. Calculate the empirical formula of this compound. This is what I said in here. You can put in the percentages instead of the masses, and we will work exactly the same. So our first step is to find the MR of each of these. So Na, this is 23, for Cl, this is 35.5, and for oxygen, this is 16. To find the masses. So for Na it's 21.6%, for chlorine is 33.3%, for oxygen is 45.1%. And this is our hardest part, or really not hardest, but the one that takes the most of time. This is our step 3. For Na, number of moles equals mass, which we use the percentage, 21.6 over mR, which is 23, and this gives you 0.94. For chlorine, this is 33.3 over 35.5, and it gives you 0.94 as well. And for oxygen, this is 45.1 over 16, and this gives you 2.82. You divide by the smallest, so you divide all of these by 0.94. So 0.94 divided by 0.94 is 1. 0.94 divided by the smallest, which is 0.94, is 1 as well. And 2.82 divided by the smallest, which is 0.94, equals 3. So this is our ratio. Na, one of them, Cl, one of them, oxygen, 3. And we also got part B. What other information would you need to know to be able to calculate the molecular formula of this compound? So the empirical formula is the easiest ratio, and the molecular formula would be the most difficult one. Or maybe not most difficult one, but the actual ratio. If you don't know what I'm saying, visit my blog. I explain everything in there. So, what other information would we need? So, this could look like this. Everything times by 2. But it could also look like this. Everything times by 6. So, in order to be able to show the molecular formula, we would have to know the MR of the compound to know how many times it would have to be times by. So the answer is the MR. Next question. Epsom salts is a form of hydrated magnesium sulfate. It can be represented by the formula. It looks like this. When 7.38 grams of this hydrate was heated, 3.60 grams of the anhydrous salt, magnesium sulfate, remained. Calculate the value of X, the one right here. So, there's certain steps you'd have to take in this type of question. And the first step I usually take, because I know everyone has their own way of doing this, but I usually do it like this. I find the MR of this part. The MR of the magnesium sulfate. And the MR of this goes 24.3 plus 32.1 plus 16 times 4. Which gives you 120.4. And this is because you have to find the number of moles of this salt. Mass over MR. You said that 3.60 grams of the anhydrous salt remained, so this is our mass over MR we just found, and this gives you an answer of 0.0299. Because you gotta imagine this. If you have this at the beginning, then it was heated, and then you've got the magnesium sulfate and water separately. The water has been evaporated because it was heated. So you remain with 3.60 grams of this. And whatever left, which is 7.38 grams minus 3.6 grams, which is 3.78 grams, This all is the water that's evaporated. So if you know the number of moles of this, and you know the number of moles of this water, which is 3.78 as the mass, and MR of water is 18.02, and the answer is 0.2098. This is the number of moles of one molecule of water, and we have to find how many of these molecules there is. It's 1-to-1 ratio. So our last step is to see how many more moles of water there is compared to the number of moles of sulfate. And this gives you 7. Therefore, x equals 7. I hope you do understand what I mean. Let me repeat that again. So you find you've got this, it's hydrated. The anhydrous part, so magnesium sulfate, is separate from H2O because H2O just evaporated. We know the mass of this produced is 3.6, and it was 7.3 at the beginning, so the mass of water that's gone is 3.78. You find the number of moles of magnesium sulfate, you find the number of moles of the water is just for one molecule of water. As you can see, it's going to be 1-to-1. It's not going to be 1-to-1 ratio because we're trying to find that number that should be here in front of water. So we're trying to see how many times water is bigger than the sulfate. So we divide the bigger by the smaller number, and this gave us 7. So water is 7 times bigger than magnesium sulfate. So our missing number here is number 7. Our next question. Titanium is manufactured by heating titanium chloride, 4-chloride, with sodium. This is the equation. What mass of sodium is required to produce 1 ton of titanium? So, we know sodium is needed to produce titanium. 1 ton of titanium is formed. So we know the mass. We know the MR of titanium, which is 47.9. So what you're going to do is find N. We can leave it as this, as tones. And then just give our answer in tones. This is the number of moles of titanium formed. We also know that sodium has an MR of 23. We can figure out the ratio between titanium and sodium. Titanium is 4-to-1. So if our number of moles for titanium was 0.021, our number of moles for sodium will be 4 times 0.021, which is 0.084. Once you know this, you can calculate the mass of sodium that was used because we also know the MR. Mass equals N times the MR. 0.084, we just found this, times MR, which is 23, and this gives you 1.9. But remember, we calculated this in tones. Next question. Calculate the percentage composition of carbon, hydrogen, and oxygen in propanol. So this is our propanol. The MR of our propanol is 12 times 3 plus 1.01 times 7 plus 16 plus 1.01, and this gives us 60.08. That's our first step. Now we've got to find the percentage composition of carbon. So we've got 3 carbons, so the MR of carbon in this compound is 36 grams. Not grams, 36. To find the percentage of carbon in this whole compound, you do 36 over the whole times 100, and this gives you 59.9%. Next is our hydrogen. got 7 hydrogens, which is 7.0. I'm sorry, I missed one. We actually got 8 hydrogens, which is 8.08. Again, to find a percentage, you do hydrogen over the whole, times it by 100, and this gives you 13.4%. So this was for carbon, this is for hydrogen, and now we got oxygen. We got only one oxygen, which is 16. So to find the percentage of oxygen in this whole compound, you do 16 over 60.08, times it by 100 again, and this gives you 26.6%. This is all you gotta do. Next question is the big question. Potassium reacts with water to make potassium hydroxide and hydrogen according to the following equation. First part says balance the above equation. So on the left hand side, we've got potassium 1, hydrogen 2, oxygen 1. Right hand side, potassium 1, hydrogen 3, and oxygen 1. Now we got to change it so that the numbers on both sides are the same. So potassium seems to be the same number. Oxygen as well, but hydrogen not. So let's try writing 2 in front. So now we've got still 1 potassium, but we're not going to write this down yet. We've actually got now 4 hydrogens and 2 oxygens. On this side, we got still 3 hydrogens and still only 1 oxygen. So what you want to do is just try put in a number. Let's say just write 2 because it's easiest to start with smaller numbers. And you see that you've got now 2 hydrogens plus 2 hydrogens, which is 4 hydrogens, and you also got 2 oxygens, so they're the same now. However, now you've got 2 potassiums here, but it's easy to make 2 potassiums on this side, so they all balance now. Next part says the scientist wanted to know how much KOH he could make from 45 grams of K. Calculate the answer showing your workings. So he knows he's got 45 grams of KOH. And he wants to know, he wants to find the mass of KOH, but he knows he's got 45 grams of K. So what you want to do first is convert it into moles. So the number of moles of K would be mass over MR. Mass we know is 45 grams because he wants to make KOH from 45 grams of K. MR of K, of potassium, is 39.1. Therefore, our answer is 1.15. K and KOH, they both have 2, so they have a ratio of 2 to 2. If you divide by 2, you've got a ratio 1 to 1. So they both have the same amount of moles, so the number of moles for KOH would be 1.15 as well. We can note the MR, which is 39.1 for the potassium, plus 16 for oxygen, plus 1.01 for hydrogen. So what you want to do is find the mass. Mass is N times MR. N equals 1.15 times our MR, which is 39.1 plus 16 plus 1.01. Put it all in a calculator because calculator can do it for us. 64.5 gram is the answer. Next bit. He then wanted to know how much H2O would be needed to make 45 grams of KOH. And we have to show our workings. So now we know that we have 45 grams of KOH. But he wants to know how much you're gonna get, how much H2O you would need to make this. So again, number of moles, mass over MR, mass 45 grams, MR we just wrote here 39.1 plus 16 plus 1.01, and now the number of moles is 0.802. Now hydrogen. Hydrogen has a 2:2 ratio as well. Divide by 2 is 1:1. This means they both will have the same amount of moles. But you want to find mass, so you want to rearrange the equation. Number of moles, 0.802, times the MR of H2O, which is 2.02, because we have two hydrogens, plus 16 for the oxygen. And this gives you a final answer of 14,445.45 grams. And the very last question for this unit, for this topic. Benzene, a hydrocarbon, has an MR of 78 and contains 92.3% carbon. Determine its molecular formula. So, you know, benzene is a hydrocarbon. Hydrocarbon means it's going to have only hydrogen and carbon in it. If we know 92.3% is a carbon, the rest must be hydrogen. So 7.7%. For carbon, do you remember our steps? We have to find the empirical formula first to then find the molecular formula. So as you remember from our empirical formula, you have to find the MR of each first. MR of carbon is 12. MR of hydrogen, it's right here, it's 1.01. Second step was a mass, but we can also use percentages, which we will. 92.3. And for hydrogen, we just found 7.7. Now, our last step of finding empirical formula is finding the N, number of moles. 92.3 over 12. We use the percentage as a mass. And this gives us 7.7. For hydrogen, finding the N is also mass over MR. And this gives us 7.6. We divide by the smallest. This gives us 1. This gives us 1. There might be a small decimal place in here, but it's still 1 because the decimal is too small. So 1:1 ratio, so our empirical formula is this. However, we are trying to find the molecular formula. And we know the MR is 78. So the MR of this one would be 12 plus 1, 13. So what you want to do is divide 13. It's divide the 78 by 13, which gives you 6. So 6 of these gives you MR of 78, which is benzene. So we know that we have to times R by 6. So C6 and H6. And this is our formula for benzene. And this was the last question. If you want a copy of these questions, please email me or let me know any other way. I leave all the links in the description box below. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. Like, subscribe, and see you soon. Bye.